So I want to talk about a very simple observation that maybe some have noticed as you start looking at things. For example, if I have a periodic signal in time, that the samples in frequency have a very sort of regular pattern. For example, if I have this sort of periodic signal and it keeps repeating up and down, and it's a nice sinusoidal pattern, or a nice sort of pattern with multiple sinusoids, I can do a Fourier series of this, and lo and behold, I get a whole range of different samples. And you think, that's cool, right? And this kind of gives you a very nice sort of structure. Here's an interesting thought process. This immediately begins to make you realize that there's something more to frequency. Particularly if, imagine I make the periodicity of this being a longer and longer time to where it goes to infinity, like there's no periodicity. The distance between these shrinks smaller and smaller and smaller. Okay, so if it gets smaller, then what? So if those are getting smaller, this becomes, I start noticing there's almost a continuous nature in frequency. So that's cool. But here's the second thing that happens. Imagine if I had in this continuous nature in frequency something that was periodic in the frequency space. So say there's some frequency f naught, and it just kind of keeps repeating and repeating and repeating at the same pattern all the way through. And you think, well, that's kind of an interesting pattern, but what do I get in time? Well, I actually get something in time that looks like samples. It's exactly sort of the reverse of this. And in fact, one of the things that you find is that between time and frequency, there's an interesting duality between the two medium, between the two approaches, between the two measures. And so this is something to notice that, okay, if I actually want to do this and have samples, and why do I want to have samples? Well, often I want to get something that's a continuous time, continuous valued signal into a digital computer, which is discrete time and discrete signal. I need to sample it. Well, what am I going to get? I'm naturally going to be creating signals that do this from a continuous signal. Okay. So that means that by having this sort of sampling structure, it means I'm going to get periodicity and frequency. You think, okay, now that's going to cause some problems because depending on that periodicity, I might have things, be periodic in a nice sort of nice separated way, or they might overlap. Well, what do I need to make sure of? Well, I need to make sure of that however fast I sample this, it is at least twice as fast as all the highest frequency. This goes back to a theorem from Nyquist and comes down to if I sample at 2x or higher of the highest frequency that's available, so in other words, there's nothing beyond that in this sort of one space, so go from f naught, think of f naught to minus f naught. If I do that, then I guarantee I can perfectly reconstruct it because I'm not going to get the next one, and the next one I just need to somehow perfectly ideally filter it. Whole nother question, but assuming you can do that, you can make this work. And it's very interesting to see this duality in this way, and then it allows you to start to think about the different pieces and parts and constraints that we have in these spaces.